Things we are learning today. Number 1, we are learning how to find the sum of two vectors. That's objective number 1. And objective number 2. Well, actually, for this, we're going to learn what we call the triangle method. I never call it the triangle method. I actually call it tip to tail. And the parallelogram method. Self-explanatory when I show you. Okay? Second thing we're going to learn is how to multiply a vector by a scalar. Okay? Now, we need to talk about what are the different pieces of a vector. So we're going to start with that. What are some of my different pieces of my vectors? We've got the vocabulary on one side, and I've got your things right here. So we talked about it. Point A right here. Point A is going to be right here. This is called your initial point. Notice the vector is written from a starting point, goes this way, and goes to an arrow. If that is the initial point, what do you suppose the other end is? Yes, the terminal point, where it ends. Initial meaning start, terminal meaning end. We call a vector, this vector right here would be called vector AB with an arrow on top. Okay? It is not a ray. It does have a beginning and an end, but it does have an arrow on the top, okay? Now, moving on to the next chunk. When we draw a vector, we often draw the vector starting at the origin, okay? And then going to some other point. To do that, we would call this vector AB A would be here and B would be here. In other words, this would be the point AB. Hang on. Let's do this the right way. If this is the point AB, then this would be called vector AB if it starts at the origin. Any vector that starts at the origin is in what we call standard position. Okay, so that's standard position here. Now, two vectors can either be pointing in the same direction with the same slope or in different directions, exactly different directions with the same slope. If they're pointed in the same direction, what type of vectors do you think they are? Parallel vectors. Both of these are parallel vectors. Notice they're like parallel lines, aren't they? However, parallel vectors have the same slope. Now, what happens if they're going in the same direction? In other words, they're the same length. If they're the exact same length and they're going in the exact same direction, they are what? Equivalent. You got it. Same size, same direction. Now, what happens if they're the same size but they're not the same direction, like this next pair over here? What do you suppose these guys are? Opposite vectors. In other words, they're going in exactly opposite direction. They are the same slope. They're opposite directions. So these are opposite vectors. Now, got one word left. What do we call it when we add up two vectors and we get the result of that? The resultant. Sure do. It's called the resultant. This is the sum of two vectors or more vectors. Okay? How are we doing so far? Yes, sir.
Do I gotta email somebody for my system?
No, I will. We're not gonna be able to do it today. I forgot all about it over the weekend. I'm sorry. All right. Match each quantity. Okay, so when we are doing vectors, when we are looking at vectors, we need to talk about how we orient a vector to the coordinate plane, okay? In other words, how do we figure out where they're at from standard position? Okay, so from standard position, we have a couple different ways we can do this. We can do what we call standard from the horizontal. From the horizontal, in other words, this is what I call standard. We measure counterclockwise from the positive x-axis. Okay? Counterclockwise from the positive x-axis. So which one of those shows counterclockwise from the positive x-axis? A, B, or C over there? Which one? A. Okay. So if we wanted to talk about 210 degrees to the horizontal, that would be number 2, wouldn't it? 210 from the to the horizontal, that would be starting here, going around, and this would be 210 degrees. Okay, so this would be A. This is standard position, okay? This is the standard way to measure. There are 3 ways to measure, though. The second way to measure is what we call quadrant bearing. Guys, quadrant bearing means we measure from one of the compass points, okay? We measure from a quadrant point. In other words, it's going to give us a direction, a degree, and then another direction. Let me give you an example of what that looks like. If we have this, and we have this guy over here, and I'm going to say this is 15 degrees. You know the compass points, right? Do you know the compass points? North, south, west, east, right? So this guy is starting on which axis? North, south, east, or west? Starting on north, isn't it? And from north, so this would be north. What direction are we going from north to get to that vector? So we're ending up going east, and how many degrees east did we go? 15 degrees. Do you see how it works? North, 15 degrees east. It tells you where it's starting, how many degrees to go, and what direction to go those degrees. So I want you to take a look at this. This one says 15 kilometers per hour at a bearing of south 40 degrees east. So which one would that be? B or C? So it would be C, wouldn't it? Because this is south and this is east. So we're starting south and going towards the east. So this would be C. Okay? North, 60 degrees west would then be what? Yep. This is north and this is west, so we're going to start at north and go 60 degrees west. So this would be B. Does that make sense to everybody? The last one we have is what we call true bearing. This is what they use in navigation. True bearing measures from true north clockwise. What that's going to look like is, say we go to here, and this is 15 degrees. We would write this as 0, 1, 5 degrees. True north is here, isn't it? So we're going to go clockwise 15 degrees. We always use 3 digits for true bearing. 3 digits. Okay? And if it's from the horizontal, it will say from the horizontal. If it doesn't say from the horizontal, guess what you have to assume it is? True bearing. Okay? So now let's look at another one. Let's say it was over here. This would be, let's say this was 160 degrees. That is 160 degrees. We would just write that as 160 degrees true bearing. Okay? But it's going clockwise, whereas from the horizontal or standard bearing goes counterclockwise, doesn't it? Does that make sense to everybody? So you have to pay attention to what they're telling you the measurement is. Is it in standard bearing? Is it in true bearing? Is it in quadrant bearing? Okay? All right. Now, we're going to come back to, well, we'll go ahead and do this now. Then we'll get a little deeper into each piece, okay? This is kind of an overview of what we're doing today, and then we'll get a little deeper into some, like, how do we draw them? How do we get a resultant? What are we doing? Courtney's pushing the handle of a snow shovel with a force of 350 newtons at an angle of 58 degrees with the ground. So this is going to be how we use vectors, all right? This is how we use them in physics. We're going to draw a picture. It says, draw a diagram that shows the resolution of the forces that Courtney exerts in the rectangular components. Okay? She's pushing. She's got a snow shovel, doesn't she? Pushing on the ground at, how hard is she pushing? Yep, this is our force. We are pushing down with a force here of 350 newtons, big N for newtons. Where does that angle go? With the ground is pretty much saying what? From here to here, isn't it? Do you agree? So this is where our angle goes, 58 degrees. Okay, now it says let's exert this in our rectangular components. This is easy to do because you've already done it. Our x component, the formula for your x component is going to be r cosine theta. And the y component is going to be, guess what? Doesn't this look familiar? We've done this already. That's why we did parametrics before we did vectors, because parametrics are just types of, or polar are just type of vectors, aren't they? Think about it. The notation's pretty much the same. You're going around with the degree and you're talking about a length, aren't you? Now, we do have to figure out whether it's positive or negative, etc. Okay? So how do we figure out whether it's positive or negative? It didn't really tell us whether it's positive or negative, did it? So we're just going to say magnitude, number one. Magnitude means absolute value. So it's always going to be positive. So if it asks you for a magnitude, this is always going to be positive, okay? So how do we figure out what this is going to be? Well, we think about it this way. If we've got this 350 degrees here, what we're going to do is we're going to turn it into a right triangle. This is our x, and this is our y, and this is our angle. So our horizontal component, x, is going to be, what is the magnitude here? What is r? What is my resultant or my magnitude of this thing? In this formula, what does this stand for in my picture? Yeah, 350 times the cosine of what? 58 degrees. And we'd use our calculator for that. So somebody figure out what 350 cosine 58 degrees is. Make sure you're in degrees, though, and not radians. Okay. So about 185.5. That would be newtons. Okay. And then y is going to be what? Yep. 350 sine 58 degrees. About 290 what? 0.8 newtons. Okay. So the horizontal component is about 185.5. And the vertical component is 296.8. So this really isn't that hard, is it? Not too bad? Okay.